between this first set of 4 and the second set of 4 is... So the difference between this one and the next set is these are just polynomial. So you notice there is no denominator. So you really don't have to worry about your domain as much, because for the most part, there's not going to be a break in your graph. It's going to be a continuous graph, which is why this guy asks for like end behavior, holes where you bounce, holes where or zeros where you bounce, zeros where you go through. It doesn't really ask about asymptotes or holes, because these are all continuous functions. All right. The next group has denominators. So when you have a denominator or anything like a radical, like a square root, that's when you have to start worrying about, is there possibly a break? Is there something that's going to cause a problem? A 0 in my denominator. Okay. And so this set of questions is like the one that was, I think, on your first quiz, where it's like, what are the maximum number of turns the graph can have? Determine the zeros, state the multiplicity if a 0 has a multiplicity, x-intercepts where it crosses, x where it bounces, describe the end behavior, sketch the graph, okay? And so when you're looking at these, maximum number of turns, that's really simple. You can do that with 0 work involved pretty much. Your max number of turns is just going to be 1 less than your degree. So you're going to take that degree of 4, 1 less than that, the max number of turns is 3. So that's one that everyone should get, okay? The next thing it asks for is determine the real zeros and state the multiplicity. So this is where you may have to go back and use some of the new stuff that we have done since your last quiz, all right? You do want to factor this guy if possible. So we have x to the 4th plus 4x cubed plus 5x squared plus 2x. So anytime you can factor something out, you want to factor it out, because when it's asking for zeros, it's really asking for what makes this guy 0. That's what it's asking, okay? So the first thing I notice is I can take out an x. So I can say, well, I can take one x out. I get x cubed plus 4x squared plus 5x plus 2. So automatically, if I am looking at my zeros, I know at least one of them happens right here at x equals 0, okay? So I can go ahead and put down 0 there, because setting that guy equal to 0 is easy. Anytime you pull out a variable, 0 is going to be one of your zeros. If I had pulled out an x squared, that would be 0 multiplicity of 2. If I had pulled out an x cubed, that would be 0 multiplicity of 3. Okay, this is x to the first, so it doesn't have really a multiplicity other than 1, obviously. Now, at this point, I'm going to look at this guy that's left over and see if I can factor it. If it is a quadratic, what do I mean by quadratic? My degree is 2. Then at this point, I can solve for my zeros. I can either factor it or use quadratic formula, okay? If it is a degree of 3 or more, you're going to have to use another method. Sometimes factoring works because you can factor by grouping. You should be able to glance at this guy and recognize factor by grouping is not going to work, right? If I pull out an x squared, I get x plus 4 and a 5x plus 2. So grouping is not going to work here. But now I have some other methods. I can look at my end constant here, which is a 2. My factors here are 1 and 2. And my factors here are 1. So I can put these over that. Positive and negative 1, positive and negative 2. If I have rational zeros, that's where they're going to happen. And so I can use the method of doing my synthetic division. Negative 1, negative positive 1, negative 2, positive 2, and seeing if that works. And so you can use synthetic division here and see if you have something that works. Because if you find one that works, you will drop a degree and you will then have a quadratic that will either be factorable or quadratic formula. And so do your synthetic division here. So I have a 1, a 4, a 5, and a 2. Drop down my 1, multiply. Drop down a 3, multiply. Drop down a 2, multiply. And yes, it works, okay? And so I know that negative 1 is also a 0. So at this point, I have 1x squared plus 3x plus 2. That guy is factorable. Factors of 2 that add up to 3. That's going to be 1 and 2. When you set those equal to 0, your zeros happen at -1 and -2. Well, I've already written -1 down. I have -1 again. What does that mean about -1? It has a multiplicity of 2 because I did it twice. And then I also have a 0 at -2. Those are my zeros. 0, -1 happens twice, and then -2. All right? So then I need to say, well, where does it cross? And where does it bounce? You can say bounce or not cross, however it is. All right? It crosses everywhere that has an odd multiplicity. Well, that happens at 0 and -2. Those only happen once. It bounces where it has an even multiplicity. Well, that happens at -1. So once you find your zeros, you need to define them. Does it cross? Does it bounce? Does it not cross? All right? So I have really answered a few of these questions, right? I've answered my max number of turns. That was number 1. I have answered determine the zeros and state the multiplicity. And I've answered where it crosses or where it does not cross. All right? The last thing I need to do before I sketch this is do my end behavior. Remember, this is just my shortcuts, right? So my end behavior here is just going to be looking at my degree and my leading coefficient. So my degree here is 4, which is even. That means they go the same direction. My leading coefficient, or the number in front of that x to the 4th, is positive, which means they both go up. So that means my end behavior looks like this. The limit as x goes to the negative side is going to go up, positive. The limit as x goes to the positive side is also going to be positive. It's going to go up. So then I need to graph it. All right? To graph it, I want to note where my zeros are. I have a 0 at -1. I have a 0 at positive, or at -2, and at 0. 0, -1, and -2. All right? I know that I cross at -2 and 0. And I know that my ends are going to be up here. So I know I'm going to start from up here, and I'm going to end up here. Okay? And in that process, I am going to cross at -2. I'm going to bounce off at 1, and I'm going to cross at 0 and go back up. And that looks a little different, but you get the idea. All right, so this is asking for several things. They want wholes, intercepts. The reason I listed it in that order is your wholes and intercepts will come from the numerator. Wholes will also affect the denominator. But basically, your intercepts are where your numerator equals 0 unless it is a whole, okay? So when we start doing this process, we're going to see, does anything cancel out? That's a whole. If it doesn't cancel out and it's on top, that's an intercept. If it doesn't cancel out and it's on bottom, that's a vertical asymptote, okay? It also asks for horizontal asymptotes. That is your shortcut. If my denominator degree is larger, my horizontal asymptote is y equals 0. If they're the same, 2 over 2, degrees over degrees, whatever, then you're going to use the coefficients. And if the one in the top is larger, then you're going to have to do your long division because you're not going to have a horizontal, you're going to have a slant. A slant, okay? So let's look at this one. The first thing I want to do is, can I factor anything? And I can. So the top is factors of -2 that subtract to give me 1. So for that one, how do I factor it? X plus 2 and x minus 1. On the bottom, do I have something in common? Yeah, I have actually a -3, right? So I can take a -3 out and I'm left with x plus 1. All right? So does anything cancel? No, it does not. Which means everything that makes my numerator 0 is going to be an x-intercept, right? It's going to be a 0 of the function. So had I crossed anything else, I would have had a whole. But since I can't cross anything out, my numerator, those are all x-intercepts. So I can go ahead and straight to my x-intercepts. My intercepts will happen where this is 0, that's at -2. And when this is 0, that's at +1. Those are my x-intercepts. Whatever makes my numerator 0 but did not cancel. Had it canceled, it would have been a whole, not an intercept. Okay? By doing that, I actually answered my next question, which is wholes, or the question before it, rather. If all of my numerator ended up being intercepts, none of my numerator can be a whole, right? So had one of those numerator groups canceled out, I would have had a whole. But I didn't, so I'm going to say there are none. There are no holes on this one, this particular graph, all right? Horizontal asymptote, horizontal asymptote. Now this is where I can look at my degrees. So for this one, I have a degree bigger on top than on bottom, which means this is an improper one, which means I am going to have a slant, not a horizontal. So if you look at this, let's say my denominator had a larger degree, y equals 0, that would be horizontal. Let's say it had been x squared over -3x squared. That would have been 1 over -3 horizontal. But I have an x squared over an x, which means I'm going to end up having a slant, not a horizontal. So you actually have no horizontal asymptotes here. All right, because my degree on top is bigger. When your degree on top is larger, you do not have a horizontal. You actually have a slant, okay? And when you learned those rules last year, which I'm pretty sure we did, we just stopped at no horizontal asymptote, right? We didn't even go into slant. So no horizontal asymptotes here. All right, let's look at vertical. Vertical is where my denominator is 0 but does not cancel out, okay? Well, nothing canceled out. We've already determined that when we look for holes. So everything that makes my denominator 0 is going to be a vertical. There's only one. It's right here. So at x equals -1, I'm going to have a vertical asymptote. All right? The last thing I asked for here is slant. In order to do slant, you are going to have to do long division. Okay? So for slant, we are going to divide the top by the bottom. So the top goes on the inside, right? And we have x squared plus x minus 2. Again, you have to start at your highest and go down. I had an x squared. I must have a placeholder for x. I must have a placeholder for a constant, okay? On the outside, I have -3x minus 3. We're just going to do long division here. That's fine. -3x times what equals my x squared plus 1. Yeah, we're going to have a -1/3, which you can for a linear, right? That's okay. All right, so we have -1/3 x. Yes, it's hideous. It's okay. It will cancel out with that -1/3, I promise. -1/3 x times -3x. Well, that just gives me a +1 x squared. -1/3 x times -3 gives me a positive x, right? Yes? We're subtracting. So remember, you're adding the opposite. Both of these cancel, right? I'm left with a -2. Remember, when my degree is lower, I'm done. That's my remainder. So it's going to be -2 over -3x minus 3. Okay? So this first piece represents my slant. This linear piece before the fraction represents my slant. My slant's going to be a line. Y equals mx. Right? I did not have a plus b there because I did not have a... They both canceled out. Had that x not canceled out, I would have had one more before I had a remainder, and you would have had a plus b, which means I'm going to cut through 0. I mean, 0 is my y-intercept there, right? So then how do we graph all of this? I'm going to start up here at my intercepts. X-intercepts, I'm going to graph those. -2, 0. That's going to happen right there. positive 1, 0. That's going to happen right there. I don't have any holes. I don't have any horizontal. I have a vertical at -1. So at -1, I am going to do a vertical line. It's not part of my graph, so I'm going to dash it. So to graph this piece right here, I'm just going to do a dashed line at that -1. All right, dashed line there. Okay. The next piece is my slant. I'm going to graph this just like I would y equals mx plus b. My b is 0, so that means my y-intercept is 0. My slope is -1/3. That's down 1 over 3, okay? Or up 1, left 3, okay? And so I'm going to graph this line right here with a -1/3 slope. And it is also going to be dashed because it is just a directional line. It's not part of my graph. It's just telling me the direction to go. Now this gives you a picture of what's happening to the graph, right? I do actually have a y-intercept, okay? And I think on your test, I actually asked for y-intercept because it helps you in your graphing. So when you did x-intercept here, that was just your numerator. Y-intercept, you just plug a 0 in for all your x's. So you would say 0 squared plus 0 minus 2 over -3 times 0 minus 3. What do you end up with? -2 over -3. So your y-intercept is 2/3. So that actually tells you you're going to cross your y-axis around 2/3. Okay? Does that make sense? Y-intercept, where you cross your y-axis. This gives you a picture of what's actually happening here. Okay? You're actually going to then just sketch this guy. You can't cross the x any more than what we've already determined. So this is going to have to be up here somewhere. And he's going to do this little thing here. He's going to start over here. He's going to cross the y-axis and the x-axis and go this way. All right? So it gives you this little picture of what's happening to that graph.